Hello, and welcome to the Designing Impactful Innovation podcast. I'm Clara, your host, and today we're talking about the trends and challenges of hydrogen in aviation with Dr. Lisa Belkhichane, Aerospace and Defense Industry Sustainability Value Expert at Dassault Systèmes. Hello, Lisa, and thank you for joining us today.
Hello, Clara.
It's really great to hear from you today. So, first of all, could you please tell us a little bit about yourself and what you do at Dassault Systèmes?
Yeah, sure. So my name is Lisa Belkhichane, and I am at Dassault Systèmes for 3 years. My role in the aerospace and defense industry is to gather and understand, together with customers and with the many other people at Dassault Systèmes, the major changes and trends towards sustainable aviation in order to align our solutions with the new industrial needs.
All right, thank you. So, today we're focusing on the use of hydrogen in the aviation industry. And as our expert on this topic, what would you say to convince aerospace companies to adopt hydrogen as an energy source in the short to long term and for different flight missions?
Yes, so first, I think it's important to recall that the aviation industry has been facing for decades the challenge of reducing its carbon footprint. And this industry has made significant progress in fuel efficiency. That's why, for instance, we will have a flight today which will generate just 50% of CO2 compared to the same flight back to 1990. And this improvement has been achieved in particular through incremental advancements on the engine, on the airframe, and also through the inclusion of new, lighter, and efficient materials. So the decarbonization is not something really new for the aviation industry, but it's right that today this industry is committed to achieving net zero carbon emission by 2050. And to meet this really important objective, innovative aircraft and propulsion systems need to be developed, and we will see totally new architecture coming in the following decades.
Lisa, could you tell us what that will look like?
So, if we give a panel of what is coming in the upcoming decades, first we will see electric flight, especially for smaller aircraft, and also more electrical aircraft for the short range missions. This is particularly the case for the smaller aircraft, where we will see eVTOL, so electric vertical takeoff and landing aircraft, in the so-called urban air mobility market. And Dassault Systèmes is really supporting these new pioneers of aviation, like with Vertical Aerospace in the UK, Joby Aviation in the US, or even Ascendance Flight Technologies in France.
So, what can we do about longer distances?
We have talked about smaller aircraft, and when it comes to medium and long range destinations, but as well the medium, long, and timeline, which means that for 2050, we will see hydrogen propulsion considered as a really promising technology, either in the form of a hydrogen fuel cell, which will empower electric engines, or for combustion in order to increase thrust and also to being able to empower long-range aircraft. So hydrogen is a key part of the solution, not only because of its unique property towards energy density, but also because it eliminates completely CO2 emissions in flight and can be also produced carbon-free if we are talking about green hydrogen. So this is more a matter of production here, but we will talk about that later. And this is, for instance, the important cornerstone, so the hydrogen propulsion, which has been chosen by Airbus in the design of future zero-emission airplanes expected to be commercialized in 2035 in the Zero E program at Airbus.
Okay, so to recap, electricity is only an option for shorter range travel, and hydrogen propulsion is best suited for longer distances. So, in your opinion, what are the biggest trends and challenges today for the use of hydrogen in aviation? And how can shifting towards hydrogen fueled systems now help advance sustainability?
So yes, indeed, this shift to hydrogen is not without some challenges. If we stay at the aircraft level, just at the aircraft level, the most important concern is related to the onboarding of hydrogen storage itself. Compared to kerosene, the very low density, together with the cryogenic characteristics of liquid hydrogen, can result to very huge tank shapes that are really challenging to integrate into an aircraft. We will probably see coming totally disruptive aircraft architecture for civil aviation, like the blended wing aircraft that is also part of the Airbus program, just in order to being able to store more hydrogen in the aircraft in order to fulfill the long range mission. But other hydrogen systems, not only storage, but other hydrogen systems will need to be improved, like fuel cells. Fuel cells are also a key element in this hydrogen aircraft story, because just as hydrogen tanks, we cannot provide and develop hydrogen aircraft architecture without using a hydrogen fuel cell, either as a non-propulsive source of energy to empower all the electric consumers on board, or to as a propulsive source of energy to empower electric engine. So in a way or another, we will have hydrogen fuel cell on board. And these fuel cells need to be improved in terms of performance, and so in order to improve the power density. And to do so, we will need to work on this performance and especially on the heat management of the fuel cell, on its materials and many other deep components of the fuel cell, just to be sure that it will meet its efficiency in terms of performance for particular long-range aircraft missions. And if we talk about hydrogen combustion, so we were saying before that hydrogen combustion will be required for a long-range mission where traditional engine will be still the best suited for this kind of missions. So even with hydrogen combustion, we will still have other challenges, especially towards non-CO2 emissions that will be emitted, like nitrogen oxides or even water vapor, which contributes to contrails and to the environment at the higher levels in the atmosphere.
Okay, so you talked about hydrogen storage, fuel cells, and hydrogen combustion. Um, I'm guessing that just like with planes that run on fossil fuels, an entire infrastructure is needed to make hydrogen-fueled planes work. Could you please give our listeners an overview of the infrastructure we need to develop in order to support hydrogen-fueled aircraft?
Yes, you're right. This will require at first airports to reinvent their existing infrastructure and logistical systems. So not only airport, but also all the hydrogen value network. And this is really important because first, even at airports, we will talk about hydrogen storage. It's not only a matter of hydrogen storage system in the aircraft, but also how to build efficient hydrogen systems at the airport in order to reach the mission to deliver on time the proper amount of hydrogen which is required for a mission. So all the technological challenges that we have for hydrogen storage are still valuable for airport infrastructure, indeed. And on the other side, hydrogen must be transported from its producer to the airports. And here we are talking about all the supply chain and value network. And this is why a strong collaboration among the hydrogen value chain need to exist first and to be optimized in order to reach all of these challenges successfully.
And are there any tools that can help industry stakeholders make the design and implementation of these systems easier?
The virtual twin experience is indeed the digital expression of a product or even the industrial system itself in defining the way it is shaped, the way it behaves, and the way it interacts with other systems. And it's always start from the earliest planning and design stages of the product life cycle through manufacturing, operation, sustainment, and disposal. So that's why the virtual twin experience enables, in particular, aerospace and defense companies in the context of decarbonization to explore scenario and in a collaborative manner, and in order to predict future behavior and deliver the right solution at scale the first time. With this virtual twin experience provided by Dassault Systèmes, these companies can thus create live virtual replica of hydrogen and battery electric system we were talking about just earlier, but also virtual twin of the new aircraft architecture itself, and even the virtual twin of the supply chain itself, all before the real-life application of such new aircraft. So that's why the 2D experience platform not only accelerates hydrogen aircraft design process, but also it helps in the daily operation of airlines and all the aircraft stakeholders to optimize the supply chain and airport operation to be more efficient in the adoption of such new energies like hydrogen and also electric flight systems.
So I'm guessing that new hydrogen-fueled aircrafts come along with new certifications, which also means new challenges for the companies who design these systems, right? Can you tell us a bit more about the certification process for hydrogen aircrafts or systems?
Yes, so aircraft certification standards are moving fast just as aircraft technologies are evolving too. And the commercialization of eVTOLs aircraft, so the new electric vertical and takeoff landing aircraft, will be strongly dependent on the way the solution can reduce its acoustic signature and meet stringent certification for noise. So if we just recall that this eVTOL will be used also for urban air mobility, we will need to evaluate and assess the noise impacts in cities, and this is part of the certification process. And to meet this type certificate and new regulation that will be coming for such new aircrafts, we will need to have new way of working that combine the expertise of stakeholders and also the acceleration of the whole certification process. And that's why Dassault Systèmes is working on this digitalization of the whole certification process, both in the way the process can be all the certification governance processes, but also through the acceleration of the adoption of virtual testing in order to accelerate and be more efficient in all the test pyramid phases that are required in the certification processes. And the last point is the fact that regulators are also working to establish a certification process for this new aircraft solution. And this is why Dassault Systèmes also has the ambition to its model-based certification solution to being part of this work in collaboration with the certification agencies. As an example, Dassault Systèmes is also working with the startup Blue Spirit Aero, which is relying on the power of a hydrogen fuel cell to be a catalyst in the entry into service of the hydrogen aircrafts by 2026 through the work of the 3D Experience platform and also through the work of model-based certification.
That was so insightful, Lisa. Thank you so much for sharing all of this with us. So, we talked about the main pillars of sustainable aviation. You mentioned that Dassault Systèmes had the solutions to take part in all these pillars, whether it is electricity, hydrogen fuel cells, hydrogen combustion and storage, as well as the certification process. So thank you very much for all those insights, Lisa. That was very informative.
Thank you, Clara.
For our listeners, tune in to our next episode, where we'll continue to talk about certification and supply chain challenges of hydrogen in aerospace. For more information, go to 3ds.com/cloud. Don't forget to subscribe for more insights and stories from our guest experts.